Alright, so after an overview of the theory of kinematics, we will apply that theory to solving a few questions. Some of these questions are pretty common in IIT JEE, and it's important to apply these concepts in the form of problems in order to understand these concepts better. So we'll start off with the first question. Piyush, you please take us to the first question.
Okay, the question as it is given to you is a point moves along the x-axis and at t equal to 0, x is equal to 0, and the velocity time graph is given to you. Okay, so what you have to do is you have to draw the acceleration time graph, x coordinate versus time graph, and the distance traveled versus time graph. Okay, so initial condition is given at t equal to x is 0, t equal to 0, x is equal to 0. We will look how it will help us in drawing the graph of x coordinate. First we will start with the graph of...
So the velocity time graph is given basically, and from there we have to find the time dependence of the acceleration, x coordinate and distance traveled. So we have to draw graphs for each of them.
Yes. Okay. First we will start with the acceleration time graph. Okay, so we know that acceleration is equal to dv by dt, or that is an instantaneous acceleration.
Yes.
And for a straight line graph, we know that the acceleration is simply equal to slope of vt graph.
Yeah.
Because like acceleration is equal to delta v by delta t.
Correct.
Okay.
For a straight line.
Yes, for a straight, and like we do it for like when we approach at t limit delta t tends to 0, then we write dv by dt for instantaneous acceleration. It is a straight line graph, so like we can write delta v by delta t.
Yeah.
So and for the straight line graph, like we have equation y equal to mx plus c, so like v is equal to like
acceleration is constant.
acceleration is constant. That's a simple thing. So for a straight line graph, like here acceleration is constant, that is equal to slope of the graph. So the slope is 1 upon 1, so that is 1. So we will start drawing the graph of acceleration versus time. Okay.
So the slope of the velocity time graph gives us...
Gives us acceleration versus time.
And now we can plot that
Acceleration, yes.
period from
Okay.
t equal to 0 to t equal to
This is acceleration. Okay. And this is time. So at t equal to 0, the value of acceleration is 1. Okay.
Alright.
So like we'll plot it like 1, 2, 3, minus 1, minus 2, minus 3, this is 0. At equal to 0 to 1, it is constant, that is equal to 1. So we'll write like this: 1, 2, 3, 4, 5, 6 and 7.
So for that initial period, acceleration is
Constant, and that is equal to 1.
Yeah.
After that, the slope is equal to 0, because delta v is equal to 0 simply. So
yeah, so the slope of the VT graph is 0.
so we have graph like this. For t is equal to 1 to t equal to 3 seconds, so graph will be like
Yes,
this.
since the velocity is constant, the acceleration is 0.
Yes, delta v is equal to 0 simply. So
Yeah.
okay, so now for this slope is, we find the slope. Delta v is equal to minus 3, v2 minus v1, v2 equal to minus 2, v1 equal to 1, so minus 3, and time is 3 seconds. So slope is equal to minus 3 upon 3, that is equal to minus 1. So I can direct it directly that the slope is minus 1. So from 3 to 6, it is constant, it is minus 1.
Okay, so the acceleration is minus 1.
Yes,
This is
and
negative acceleration.
and here the v2 minus v1 we will calculate, that is equal to 0 minus minus 2, that is equal to 2. Time is 1, so slope is plus 2. So value is plus 2. After that, the velocity is constant, that is 0, and the acceleration also will be equal to 0.
Acceleration will be 0.
So this is the graph of, what do you say, acceleration versus time.
So basically, just by taking the slopes of the lines in the velocity time graph,
We can draw
find
the
acceleration.
yes. And for example, if a graph is any arbitrary curve, or this is a velocity and an arbitrary curve, we will like for any particular instant we will like differentiate it, or like find the slope by the graph if by some methods for finding the acceleration.
Yeah.
Okay, so now I also told you that for we know that the area under VT graphs gives the change in position, and it gives the displacement of the body. So like here it is given that at equal to 0, x is equal to 0. So after in 1 second, the area under VT graph will give the displacement. So that is equal to x2 minus x1. We know that x1 is equal to 0, it is given to us. So okay, so we will use it and just start doing it. This is the displacement x, and this is the time. Okay, like this is
Now we are moving on
1,
finding the
2,
displacement
yes, 3,
with respect to time.
yes,
Alright.
5, 6, 7. Okay, now what we're gonna do is like we will draw some rough graph. We'll not take the values into consideration at the moment. Let's draw some rough graph. Okay, so but we can do that also, but we'll take some time, and it's better like if you do it on your own, then we'll just like do it on rough graph. So what I'm gonna do is the change is equal to 1. Area under this graph is equal to what? Half into 1 into 1s. Okay, so area is equal to 1 by 2. So the x2 minus x1 is equal to 1 by 2. We have x1 is equal to 0 and x2 is equal to 1 by 2. Okay, for example here it is 1 by 2, here it will be 1 by 2, and we also know that this graph is a straight line graph. Okay, so the graph of x versus t will be like parabolic. Like remember this thing, you will also study this in basic mathematics. Okay, that if a graph is a straight line, if we integrate the graphs, we will have a parabolic graph. Okay, that is like this. Yes, and if you like, if you have a straight line graph like this, like in which velocity is constant, then the graph of the x versus t will be a straight line. Okay, so these are some simple things like you will also study them in basic mathematics, like simple graphs and all that. That will be covered in earlier. So okay, so graph will be like this, parabolic. Now after that the path will be straight line, and we have to find the change, that is equal to, change is equal to area under this, that is equal to 2 into 1, that is equal to 2. So finally the displacement will be 2 plus 1 by 2 simply. Okay, so let us find it. This is some 5 by 2. Let us assume this 5 by 2, and the graph will be a straight line at okay.
The graph will be a
straight line
because the velocity is constant.
Yes, velocity is constant. The graph is straight line. Yes. Okay, so and now we will find like here the velocity is positive from t is equal to 3 to 4. Now we also must remember that if the velocity is increasing, then the graph will be like this for xt, and if the velocity is decreasing, the graph will be like this. I can also explain it to you, because like at some point the slope is this is v1. Okay, this slope. Now after some time the slope is v2. We have seen that the slope has increased. That's why the graph is like concave upwards. Now in this case, initially the slope is v1. After some time the slope is v2, and the slope has decreased. We know that the value of slope has decreased. The angle has decreased, so the slope has decreased. So the graph will be like concave downwards. This is called concave upwards. Okay, so here from t equal to 3 to 4, the graph will be concave downwards, and the change will be again 1 by 2. So from 3 to 4 it will again concave downwards graph, 1 by 2 will be increased. So it will be 6 now, or whatever. We don't need to calculate all the things. Now from t equal to yes, you can exercise for you like to solve it on your own.
Easy to solve for these areas.
Yes, for the values is very easy. So I'm just drawing a rough graph. Now from t equal to 4 to t equal to 6, the velocity is negative. Okay, so velocity is negative. That means what, that displacement will definitely decrease. Okay, delta x will definitely be negative, and area, because we are also seeing that area below the x-axis, below the t-axis, if his area is negative, that means the change in the displacement is negative. Here the area
below the x-axis
is taken as negative. Arbitrarily it is taken as negative, so that we can say the change is negative. And if the area is above that, we can say the change it is increasing simply. So it is decreasing, and the area is equal to what? Whatever is area, you calculate it like half into base 2 into height is equal to 2, so area is equal to 2. I'm sorry. So we will put now it will decrease by value of 2. Okay, so it will decrease by value of 2 till t is equal to how much? 6 seconds. Okay, so till t is equal to 6 seconds, it will decrease by value of 2. Okay, then we can make it a little better. Adjust the graph till t equal to 4 seconds. It was like this, right? And after that the graph will be like this. Okay, not decrease that much, but like I'm just saying that it will decrease this much. Now what will happen is that after this, again the velocity is increasing. Velocity is increasing, but still the area is negative. But we have taken the area. This is the required area now. Okay, this area is equal to half into base into height. This area is equal to 1. we know that the displacement has decreased by 1 centimeter, by one whatever is the unit. Now, but the thing is that we have to remember that okay, displacement is decreasing, but the graph will be in concave upwards in this case because the velocity is increasing. Yes, in this case the graph is concave downwards because the velocity is decreasing. Now what will happen? Graph will be concave upwards, but still the displacement will decrease. This will be the graph. Okay. So what will happen is that till t equal to 7 seconds, displacement will decrease. Okay. It will be concave upwards. Okay, you have to remember, like drawing in the graph like this also some tricky question that can be asked in JEE. It's not an easy question, by the way. If you do it step by step, then it is easy. And after that, velocity is 0.
And
so
this will be easier to solve once you studied in maths all the
increasing decreasing function, all that. And after that, it will be very, very easy. But still, also, I'm telling you some basic idea of some graphs things.
Also, from some basic concepts and logic, you can. What kind of graph?
Yes. Like optional elimination and all that things, but like we are doing it by method at the moment. So, and after that velocity is 0, so change in position is 0 obviously, so this will be constant. Okay, so now we are
walk through the problem again.
for displacement time.
No, it's okay. You have to give us one more part.
Yes, one more part is left. Now the one more part is distance traveled. Okay, now this is some tricky. I told you in the first, like when I told you about the definition of distance traveled, the distance traveled, like in whatever direction you go, the path length is increasing. Like you are traveling some distance, so it doesn't matter if the velocity is in right direction or left direction, the distance is increasing. That's what I'm trying to say. So like in this case, till this part, till t is equal to 4 seconds, the area was positive, that means that the displacement was positive, so graph will be same. But after t equal to 4 seconds, the area is negative, but we have taken a displacement is decreasing, okay, because the change in position is negative, but still the path length is increasing because the object is traveling more and more path now. So whatever happens is that
distance is always increasing.
Yes, distance is always increasing. So whatever we took in the negative, we will just take the mirror image of that. Okay. So till t equal to 4 seconds, the graph will be same. It is such a tricky thing, very tricky thing. You don't have to think much. Just take the mirror image of this, and you will find the exact displacement time graph. Okay.
Okay. So we will leave this as an exercise.
Exercise for you.
Just calculate the areas and take the mirror image of the area below the graph and add the two areas together. You will get the distance traveled.
Yes.
All right. So we'll quickly run through the problem once more.
Okay.
So basically, we were given a point which travels along the x-axis at
yes,
equal to 0. The x position is 0, and the velocity time graph was given. And we have to draw the acceleration time, coordinate time, and distance traveled versus time graphs for these. For this problem. So basically we found out how to draw the acceleration time graph by figuring out the slope of the VT graph, and our task was made easier because the velocity is changing. VT graph is mostly composed of straight lines in this case. So correspondingly we found out A and T, positive or negative slope indicating positive or negative acceleration. After that, a slightly more complex problem of figuring out the x coordinate versus the time coordinate. So how we did this was
looking at the area.
Yeah, by taking into consideration the area under the VT graphs, which gives us the displacement. And the areas below the x-axis are taken as negative, and areas above are taken as positive, and correspondingly we can draw these things, and we can figure out whether it is concave upward or concave downward from the changes in the velocity itself. So, lastly we found out the distance traveled s. In this case, since distance is just the path length, we just added the areas under the VT curve. We took the mirror image of the negative part and just added the two areas, since the distance is always increasing.
Yes.
Even though the displacement is decreasing.
Yes.
So that's how we do it. Okay, so now we move on to the next problem. And Piyush, will you take us through the next problem?
Okay, the problem is the radius vector of a point A relative to origin varies with time ts vector r is equal to ati cap minus vt square j cap. A and b are positive constants and I and j are unit vectors of the x and y axis respectively. So
we have to genetic position vector equation.
Yes, it's genetic position, and we have to find the equation of trajectory simply, and velocity and acceleration vectors and mean velocity vector average over first second. Okay, so what we will do is first we know that here x coordinate is equal to at and y coordinate is equal to minus bt square, because simply I and j indicate unit vectors in x and y direction. So we will eliminate t to find equation of trajectory, and y is equal to minus b, t is equal to x by a, so x square by a square. This is the answer of the first part. Now we have to go and find the answer of the second part. Now we know that v simply is equal to dr by dt. We simply apply this thing, and we know that we differentiate the components of the two independently, like we know that it's
separately.
So, separately.
We differentiate the x components with respect to x and y components with respect to y.
Yeah, I mean x components with respect to time
x components with respect to time and y components with respect to time, but separately.
Yeah, but separately. Okay, so differentiating at with respect to time will give us a, and so we will have velocity is equal to ai cap, and differentiating minus bt square give us minus 2bt. The simple formula for differentiation we use. So this is a velocity vector, and acceleration vector is, in fact we know that acceleration is simply is equal to dv by dt. So we have simply it is equal to it is a constant, so differentiating it will give us 0. We have minus 2b j cap is the acceleration vector. So now what I have to find is mean velocity vector average over the first 3 seconds of motion. We know that average velocity is equal to what? It is simply equal to delta r upon t. Okay.
Delta r is the displacement.
Yes. So r at time t minus r at 0 upon t, and we know that r at time t is given to be ai cap, ati cap minus bt square j cap.
Yeah.
And r at time t will be equal to 0 because both components are 0 simply. So it will be okay. So and upon t, which will give us ai cap minus bt j cap.
Yeah.
Okay. So this is the answer. Very simple question.
Yeah, just a very simple question. I don't think we need to go through it again.
Okay.
Pretty straightforward. Just
okay. We were just given the
use the basic differential formula,
and we were given the displacement vector. We find the velocity and acceleration vector by differentiating it once and twice respectively, simply, and we also find the average velocity by using the formula. And
points trajectory can be easily
found by eliminating the time. This is the simple thing that you have to do in every question.
Okay. So the next question actually appeared in the JEE question paper of 1982, and it basically concerns, it's a pretty simple question. Piyush, will you please take us through it?
Okay, so in this question, what we are given is a particle is moving eastwards with velocity of 5 meter per second, and in 10 seconds the velocity changes to 5 meter per second northwards. Okay, so the average acceleration in this time is, we have to find the average acceleration, and it is simply equal to v2 minus v1 upon t. It's simply using the definition of average acceleration. So final velocity is, we know that 5 meter per second northwards. Okay, where is the magnitude as this is 5, and initially it is 5 meter per second in this direction. So what you have to do is, I have to subtract this vector from this vector. So what I can do is add the opposite of this vector to this vector.
Yeah, just take the negative of the
original
of v1
and add it to simple vector addition, and what I will left will be with this. So the required vector will be this. Okay, so this is north, this is west, the direction is northwest. So right now also I can say the answer is this, but I also went to magnitude also. But the magnitude
just for the sake of completion.
Just for the sake of completion. Now this is 5, the angle is 90 degrees. So obviously by Pythagoras this is 5 root 2. And what I have to do is acceleration is equal to v2 minus v1 upon t. Right, so 5 root 2 is the magnitude, and upon time, so I will be left with 5 root 2 upon into root 2 upon 10. It is equal to 1 by root 2. Magnitude of acceleration will be 1 by root 2, and the direction will be this.
Northwest.
Okay,
So pretty straightforward question.
Straightforward
Just go
question.
through it once. You
Okay.
figure it out.